Java, a language that powers billions of devices worldwide, is a cornerstone of modern programming. This powerful and versatile language has become ubiquitous, with a presence in everything from small handheld devices to vast enterprise-level systems. A good grasp of Java's foundational concepts is essential to harness its full potential. These principles, which include identifiers, modifiers, variables, arrays, and more, form the bedrock of Java programming. In the next few minutes, we'll delve into the core concepts that form the backbone of Java. Think of Java identifiers as labels on jars, distinguishing the contents within. In the Java programming language, identifiers are the names we assign to classes, variables, and methods. However, there are specific rules we must follow when naming these identifiers. They must always start with a letter, a currency character such as a $sign or an underscore. They're case-sensitive, meaning age, and age are two different identifiers. Java identifiers cannot be keywords, so naming a variable int would be a no-go. Let's look at some examples. Age, $salary, underscore value, and underscore underscore one underscore value are all valid identifiers. On the flip side, 123 ABC and salary would be considered illegal identifiers. With these rules in mind, you can now create meaningful identifiers in Java. Modifiers in Java are like special instructions on a recipe, altering the final result. In the Java programming language, modifiers are used to set rules that govern the classes, methods, and other elements of our code. They fall into two main categories. First, we have access modifiers. These dictate the visibility and accessibility of our classes, methods, and variables. We have four types of access modifiers: default, public, protected, and private. Each of these has a different level of access, allowing us to control who can see and use our code. Next, we have non-access modifiers. These don't control access, but they do influence the behavior of our classes, methods, and other elements. These include final, abstract, and strict TFP. Each of these modifiers has a unique effect on our code, from making it unchangeable with final, to allowing it to hold incomplete methods with abstract. Modifiers play a crucial role in controlling access and behavior in Java. Variables in Java are like containers, while arrays are like a shelf holding these containers. In the world of Java, we deal with three types of variables. First, we have local variables. These are declared inside methods and are only accessible within the method they are declared. Think of these as your personal items, like a toothbrush, that you wouldn't want to share. Second, we have class variables, also known as static variables. These are declared within a class but outside any method, and they can be accessed from anywhere in the class. It's like having a shared refrigerator in a communal living situation. Everyone can access it, but you should probably label your food. Third, we have instance variables or non-static variables. These are declared inside a class but outside any method, and can be accessed via the instance of the class. Think of them as your personal belongings in a shared house. They belong to you, but others can access them if they go through you. Now, let's talk about arrays. If variables are containers, arrays are like a shelf holding these containers. They store multiple variables of the same type. So an array in Java is like a bookshelf where each compartment holds a book. You can have an array of integers, an array of strings, or any other data type. In the upcoming chapters, we will delve deeper into how to declare, construct, and initialize these arrays. Understanding variables and arrays is key to managing data in Java. Imagine enums as preset choices on a menu, keywords as the language's reserved words, and comments as side notes for future reference. In Java, enums, introduced in version 5, limit variables to a set of predefined values. Picture a juice shop application where you can only choose small, medium, or large for the glass size. That's enums for you. Next, we have keywords. These are reserved words in Java that you can't use as identifiers. They're like VIP tickets, exclusively for the language's use. Words like abstract, assert, Boolean, and break are some examples. Then we have comments. These are your notes to yourself or to other programmers. They explain your code and make it more readable. Java supports both single-line and multi-line comments, so you can make brief notes or write more detailed explanations. With enums, keywords, and comments, you can write more robust and readable Java code. Inheritance in Java is like passing down family traits, while interfaces are like a contract promising certain capabilities. Let's delve into these concepts further. Picture inheritance as a family tree. In Java, You can create a new class, or child class, derived from an existing class, the parent class. This child class or subclass can inherit fields and methods from the parent, thus enabling code reuse. Just as children inherit traits from their parents, subclasses inherit properties and behaviors from superclasses. However, unlike real-world genetics, there's no mixing and matching, it's all or nothing. Now think of an interface as a legally binding contract. It's a promise that a class will implement certain methods. If a class signs this contract, or in Java terms, implements an interface, it must define those promised methods. The beauty of interfaces lies in the consistency they bring to your code. They ensure that all classes implementing the same interface adhere to the same method signatures, fostering predictability and flexibility in your design. In the grand scheme of Java programming, inheritance and interfaces are two sides of the same coin. They both facilitate code reuse, but in subtly different ways. Inheritance allows you to build upon existing code, while interfaces ensure your code adheres to specific standards. Inheritance and interfaces are vital for creating flexible and reusable Java code. So keep these concepts in your toolkit as you journey further into the world of Java. You've taken the first steps to understanding the power of Java, but the voyage of discovery is far from over. Our next video will be an exciting exploration of objects and classes in Java, the building blocks of any Java application. We'll delve deep into these key concepts, demystifying their roles and revealing how they create flexible and robust code. So, are you ready to continue this enlightening journey? Join us in the next video as we unravel the fascinating world of objects and classes in Java.